molecules and bonding. Let's begin with the question. Jonathan, can you name a molecule we might analyze today?
I think that might be H2O.
Excellent choice. Water H2O is a great example of molecular bonding. Now, what kind of bonds do you think are present within this molecule?
I think it has covalent bonds because it's made up of nonmetals, right?
That's right. Oxygen and hydrogen are both nonmetals. In water, the atoms share valence electrons, forming polar covalent bonds. The shared electrons are pulled more toward the oxygen atom because of its higher electronegativity.
So that's why water has polarity, right?
Exactly. The polarity of water leads to hydrogen bonding between water molecules, which is a strong cycle of intermolecular force. These interactions explain many of water's unique properties, like surface tension and boiling point.
What holds the atoms together in H2O?
The valence electrons are shared between atoms, creating single bonds that hold the atoms together in the molecule. In contrast, in an ionic bond, electrons are transferred, not shared.
So how do ions form?
Great question. A neutral atom becomes a charged ion when it gains or loses electrons. If it loses electrons from its valence shell, it becomes a cation. If it gains electrons, it becomes an anion.
And the octet rule helps predict that, right?
Correct again. Atoms gain or lose electrons to achieve a full valence shell, typically with 8 electrons, following the octet rule.
So how do ions combine to form crystals?
They come together in binary ionic bonds, where a positive ion from a metal attracts a negative ion from a nonmetal. This forms a repeating crystal lattice structure.
So what's an example of a model that helps us predict chemical reactions?
We use the Lewis dot structures and the valence shell electron pair repulsion theory. The Lewis dot structure shows the electron's configuration of molecules. The valence shell electron pair repulsion theory helps us predict molecular geometry, bond angles, and polarity.
Can you show me the Lewis dot structure for O2?
Sure, oxygen has 6 valence electrons. To satisfy the octet rule, each oxygen shares 2 electrons, forming a double bond. This shared pair lets each atom reach 8 electrons in its outer shell.
So how are chemical formulas written for compounds?
Good point. For ionic compounds, the formula balances the charges of the ions. For covalent compounds, the molecular formula shows the actual number of atoms. For example, H2O has 2 hydrogen atoms and 1 oxygen atom. This is shown using subscripts.
Can you explain how transition metals fit into this?
Yes, transistor metals can form ions with different charges, so we use Roman numerals in the name. For example, ion 3, chloride is Fe chloride to the 3rd power.
I think that might be H2O.
Excellent choice. Water H2O is a great example of molecular bonding. Now, what kind of bonds do you think are present within this molecule?
I don't want to leave and it's you or I.
Out of the 5 different chemical reactions, including combustion, decomposition, double displacement, single displacement, and synthesis reaction, the reaction observed in the products of the reactant CO2 plus H2O are H plus HCO3, and that's single displacement.
What is that?
As a lonely metal atom kicks out the less powerful one of the compound, making it the cation. These chemical reactions have to follow the law of conservation of mass. The mass of the products have to be the same as the reactants, making it a balanced chemical reaction. The coefficients in the chemical equation make sure every mole and molecule is accounted for. Using the molecular formula, molar mass, as a limiting reagent, we can predict how much product is made. As when the limiting reagent runs out, it decides how much product is made.
What if the product is a gas?
You need to pay attention to the phase of matter, solid, liquid, or gas.
It's important if you're doing a net ionic equation later. This equation cannot be a double displacement when 2 compounds swap ions, since one metal comes in alone and kicks another out.
What about combustion?
This reaction is not combustion, as oxygen would be everywhere and the products would be CO and HO.
When do nonmetals come in?
Non-metals are not involved with this, as they are sitting this one out, but they are still on the periodic table of elements.
Using Avogadro's number, you can calculate how many molecules are in a mole, allowing for the calculations of the molecular mass or molar mass.
I really can't trust nobody.
Let's talk about climate change. Who here knows what CO2 means?
It's carbon dioxide.
That's right. The chemical formula CO2 means that it has one carbon atom and two oxygen atoms. It makes it a double bond, making it pretty stable.
But what does that have to do with climate change?
Basically, the way the molecules stay together affects how much heat they can absorb.
What about methane?
Methane is made out of carbon and hydrogen. With single bonds, it's really good at holding heat because of its polarity and intermolecular bonding. This means that even small amounts can make the planet warmer.
So why does it measure the temperature?
Yeah, plus CO2 affects the ocean. It dissolves in water, creating ions like hydronium cations.
Cations which mess with pH levels. That makes it difficult for ocean creatures to build shells with ionic bonds.
So molecules mess with temperature.
Yeah, plus CO2 also affects the ocean. It dissolves in water, creating ions like carbonate anions and hydronium cations, which mess with the pH levels. That makes it harder for ocean creatures to build shells with ionic bonds.
What about pollution?
Factories release transition metals which react with polyatomic ions in water. Since metals don't bond well with nonmetals, they can stick around and hurt wildlife.
Yeah, so climate change does control everything.
Yeah, basically, if we understand the VSEPR theory, valence electrons and molecular geometry, scientists can predict how greenhouse gases behave. Every tiny number in a chemical formula matters.
So if we know how molecules work, we can fix climate.
Yes, chemistry helps us find solutions, carbon capture, renewable energy, and reducing emissions.
Wow, I never knew that. I'm gonna do well on my chemistry.
One-on-one, never again. One-on-one. Don't get the kick in the.
I hate Ms. Velarde's class. She never teaches us how to do lab experiments or be safe from hazards.
I know. I wish someone would teach us and help us with the risk assessment. I don't want to get a boo-boo.
I think I know somebody that can help. Their names are Noe and John. Hello? Yeah, I wanted to know if you could help us with our risk assessment. Me and Ruben really need help.
Yeah, I can help you. I'll be on my way.
You can? Alright, we'll be waiting for you up here. Alright. I think I see him.
Oh, go see what's here.
What's up, baby daddy?
Good morning, y'all. So today, we're going to be teaching you how to make a volcano. But first, y'all gotta learn how to be safe.
You guys know that chemicals could be corrosive, flammable, and toxic to human beings. So you must be wearing personal protective equipment. You guys need to also practice with electrical safety when working with electricity.
To determine if a chemical is hazardous, you guys can use the safety data sheet. Also, it is important that you guys have a good ventilation system when conducting science experiments. Now that you guys know this, you guys need to know what you guys need near you in case of an emergency.
That is an emergency eye wash station, opportunity for emergency evacuation, a fire extinguisher, and a safety shower with first aid.
Bro, can we just get started with this experiment?
Yes, we can, but we need to use the standard operating procedures to be safe.
Whatever, bro. Just tell us what to do.
Yo, watch that shit not even work. Oh, there we go.
Oh my god! Okay, now that we're all done, guys, you guys don't need to pick up the trash because it can lead to contaminating the area, since it can lead to biohazards, just like radioactive materials. I don't know.
I'm here with
Javier.
Javier. I was just gonna ask you, what do you know about lab safety?
I know a few things, Always wear your gloves, Make sure you keep the station clean.
Okay.
Make sure you, if you're gonna use a Bunsen burner, always keep it at an appropriate flame, or it's gonna, destroy your whatever you're boiling or trying to burn off in your beaker tubes or whichever glass you're using. Always clean your glass. If there's chemical residue, make sure you clean that as best as you can. Never handle anything with your direct hands, which goes back to the gloves.
All right.
And always wear your eye gear.
That's very important.
Very important. Making sure that you don't accidentally go blind. Sometimes, if necessary, wear nose gear. And if you're gonna smell chemicals, never smell it directly out of the container. Always waft it up with your hand, and then you smell it at a safer distance. You don't want to accidentally overdose yourself with chemical aromas, or however it may come down to it.
All right, thank you very much, Javier. Have a good day.
You too.
Okay, so how do we stop CO2 from going crazy in the ocean?
It all starts with the air. When there's too much carbon dioxide, CO2, in the atmosphere from stuff like cars, factories, and people cutting down way too many trees, the ocean soaks it up like a sponge. And honestly, that's not great because too much CO2 makes the water more acidic, which is super bad for marine life.
So what makes CO2 go up in the ocean?
Driving a lot, flying, and using gas-powered stuff equals more CO2 in the air. Cutting down trees equals less CO2 being absorbed by nature. Factories, power plants, and even making cement releases a ton of CO2. All that extra CO2 ends up in the ocean. Planting trees and protecting forests, trees eat CO2 for breakfast. Using clean energy like solar and wind instead of gas and coal. Walking, biking, or using public transport instead of driving everywhere. Taking care of the ocean, planting seaweed, protecting mangroves, all that green stuff helps. Just overall using less energy and waste.
Hear me?
I think it has covalent bonds because it's made out of non-metals, right?
I think it has covalent. No,
Yeah,
I'm
that's
rehearsing,
the
I'm
part.
rehearsing, I'm rehearsing.
Excellent choice. Water is a.
What does that have to do with right?
Yeah.
Oh my god.
Bro, you have one line, bro.
What it? When do metals come in?
Metals? No, that's wrong.
It's important if you're doing a net.
Wow, I never knew that. I'm at the well.
Say it louder, bro. I know you can hear you.
Bro.
Behind me.